Okay, so today we're gonna keep reviewing data structure and algorithms, and today we're gonna review the operators of sets and dictionary. So here is the operator for sets and dictionary. So let's try it out. So so first of all, when we have a set A here, set A are elements from 0 to 9. So we can print out to check if an element that we give is in the set or not. So whether an element is in the set or not. So for the first line here, I'll comment this out. So in the first line here, I want to check if number 11 is in set A or not, and number 11 whether it is, well, we want to check it is true or false that 11 is not in set A. So in this case, 1 is in set A, so this return true, and 11 not in set A, so it's gonna return false. So for example, when you print something like 69 in set A, it's gonna return false. Okay, you can see it's gonna return false for you. So that's the first keyword is in set or not. So in and not in. Okay, the first keyword is in and not in. The second keyword is about set comparison. So we're gonna talk about if two sets are equal or two sets are different. So let's have here two sets of set B and set C. Set B are all elements from 0 to 9, all integer from 0 to 9, whereas set C are all the elements from 0 to 9 with an additional 9 at the end. So let's check it out. So for set 3, set A equal to set B, that's correct because those two sets are exactly the same. But here you can see in line 4, set A is also equal to set C, equivalent to set C, even with an extra 9. Set A is all the elements from 0 to 9, and set C is all the elements, all the integer from 0 to 9 with the extra 9 at the end. But in this case, you can see set A is still equivalent with set C. This is still true in the set. If the elements are similar, they're gonna be counted as one element because all the elements in the set are distinct. So in this case, set C is only counted to have only 1 9. So A and C are also equivalent. And we can check if two sets are different. So you can see here, set D and set A is of course different because in set D we only have 3 elements, whereas in set A we have 10 elements. So set A is different from set D, or not equivalent to set D. Okay, so set A and set D are not equivalent. Okay, so the next issue is about the subset of a set. So subset and superset of a set. So let's check it out. So the subset of a set is actually the set that lies inside the set, and the superset is just the set that containing another set. So let's have a I think I want to make you a visual picture. So go to page. So let's have a big circle and small circle. Okay, so a rectangle. Okay, I'm gonna draw a circle for simplicity. Ellipse. So the bigger set, the outside set, is gonna call the superset, which is this set, and and uh, and inside we gotta call it the subset. So we call the subset. So the smaller set gonna be called the subset. So that's the picture. Okay. So okay. So in this case, uh, okay. So you can see set D and set A. So set D is actually a subset of set A. So for number 6, we're gonna return true. Set D is a subset of set A because set D are element from 1 to 9, from 1 to 3, and set A are element from 0 to 9. So you can see obviously set D gonna be lying on set A. So set D is a proper subset of set A. It's a subset of set A. It's a subset of set A, and also set set D gonna be the proper subset of set A because you know it is strictly lie inside set A. Okay, and you can see here if you print out set A smaller than set B. If set A is a proper subset of set B, it's gonna return false because set A is actually equal to set B or equivalent to set B. So you can see it returns false. Okay, so let's comment this out. So this is false because set A is not the proper subset of set B. Okay, so next what we are talking about is we're talking about the superset. So in reverse to the subset, for example, if set D is the subset of set A, then set A is a superset of set D. Okay, so you can see here. So superset is denoted by bigger or equal to symbol. So you can see here. Set A is a superset of set D because you can see set A is actually containing set D. Okay, and also set A is also the proper superset of set D because set A is strictly containing set D. So if you check for another thing, if you check for if set D is the is the proper superset of set D itself, I think this gonna return false. So you can see it's false. This is just a superset, not a proper superset. So this gonna return false. So let's just use this as a note here. So we can know that a set could be the superset of a set or a proper superset of a set. Okay. Okay. So the last piece of code we want to cover is that the union and intersection of sets. Or I think it's a couple more, but let's cover to that point. So let's talk about the union and the intersection of sets. For example, we have two sets here, set E and set F. So set E is element from 0 to 4 of integers from 0 to 4, 0, 1, 2, 3, 4. And set F being elements of integers from 5 to 9, so 5, 6, 7, 8, and 9. So to find the union of set set E and set F, so it just means you add these two sets together. You add these two sets together. So naturally you can see that we're gonna get from 0 to 9, all the integers from 0 to 9, right? So what I predict is that it's gonna give us a set from 0 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's check it out if it's correct, because we are talking about the union operator, so they're gonna add it's gonna add two sets together. So this is actually adding these two sets together for real. So that's the union operator. It's the slash symbol, and also you can find the intersection of two sets as well. The intersection of two sets is actually what elements that two sets have in common. So in this case of set E and set F, they have no elements in common, so the line element should return a empty set. So, and that's exactly what it is. So we're gonna check again with another set G we create here, and we're gonna check its union with set E here. So you can see, to check the union of set E and set G, you can see that number 3 and number 4 are a common element in two sets. So what is expected is we're gonna get the set of 3 and 4 as a return, because those two elements are the common element of two sets. So as you can see, we got 3 and 4. Okay. The next operator is that we're finding what is the element is in one set but not in the other. So for set E and set G, we can see that 0, 1, and 2 is in G, is in E but not in G. Sorry, I want to explain this again. For set E and set G, we want to find out which element lie inside set E but not inside set G. So you can see that 0, 1, and 2 lie inside set E and not inside set G. So therefore, we would expect it 0, 1, and 2 as a result for line 13. So it's actually 0, 1, and 2. So we are asking for, so the minus symbol is to find out what element lying on set, on the first set, what element is lying on the first set but not on the second set. Okay, and for number 14, we want to find out what element precisely lie in just one set. So we're gonna find all the elements inside both sets, and we're gonna subtract. We're gonna delete out the elements that is in the common sets, in the intersection of two sets. So you can see the intersection of two sets is actually 3 and 4. Of E and G, the intersection is actually 3 and 4. So we're gonna find all elements from both set E and set G, but for 3 and 4. So that's gonna be 0, 1, 2 from set E and 5 from set G. So as such, we are returning 0, 1, 2, and 5 for number 14 here. So I think that's the end of this tutorial about operators for set and dictionary. So thank you very much. We're gonna keep doing it on the next session. Okay. So goodbye.